Hi students and hi everybody. My name is Swami. I am in the Narayana group from the last 16 years. I am in the Department of Chemistry in the Narayana group. Here I want to discuss organic chemistry, especially the most important topic alcohols, phenols and ethers. Alcohols and ethers are the functional isomers. Alcohols and phenols having the same functional group OH. So, I am going to discuss cumulatively alcohols, phenols and ethers. Wherever we want, we separate for the discussion. Wherever we want, we mix and do the discussion. And before to enter into this one, what are the important areas we have to discuss in this heading? Look forward. One is the introduction and then come to the nomenclature. Nomenclature is among the alcohols, phenols and ethers. We are going to discuss together among all these three topics and then isomerism. Isomerism also here we are discussed with the alcohols, phenols and ethers and then preparation of alcohols, then physical properties of alcohols. It is a very important point regarding the physical properties. We are going to discuss in detail in organic chemistry for the comparison of their boiling points and their melting points and their solubilities. Then come forward for the chemical properties of alcohols. We are going to discuss in detail about the chemical properties of alcohols. Then test for alcohols. After that one we are entering into the preparation of phenols and then physical properties of phenols and acidic nature. It's a very important topic. Physical properties is a different from when compared with the alcohols and phenols and then acidic nature. Acidic nature we are going to discuss by mixing with the alcohol comparison and also we are going to compare the carboxylic acid's acidic nature. So, it is an important area among the phenols. After that chemical properties of phenols and then test for phenols. With these subtopics phenols are completed and then enter into the ethers. After the completion of all these areas we are enter into the ethers. Now we are going to discuss on the introduction of the alcohols. Students, what is alcohol? Generally the student says compounds having the OH group are called alcohols, right? Agreed with you. But in general where they are we are noticed in the regular life. Ethyl alcohol is a common thing, methyl alcohol is a common thing that is used in the spirit and cholesterol itself is an alcohol. A glucose itself is a polyhydric alcohol. So, several examples are there. Before to discuss all these alcohols, we enter into how the alcohol is derived. Student, take a look. Here is HOH. If you replacing this hydrogen with alkyl group, that can be considered as alcohol. In the water molecule, if hydrogen is replaced with the alkyl group, that can be considered as alcohol. Suppose if you replace two hydrogens, that is called ether. Instead of hydrogen, if you are replacing hydrogen with benzene ring, that can be considered as phenol. This is alcohol and that is called ether. Simply all these are alkyl substituted or phenyl substituted water molecules. We can define alcohols in another way. If you take the CH4, it is a methane. For the convenience, you have to write this CH3 and H. If you replace this hydrogen with the OH group, then it is called CH3OH, it is called methyl alcohol, simply called alkyl alcohol. If the CH3 is there, methyl alcohol. If C2H5 is there, ethyl alcohol. If any alkyl group is there, that can be simply called alkyl alcohol. If you take C2H5, this is called ethyl alcohol. If you take another CH3, CH2, CH2OH, that is called propyl alcohol or N-propyl alcohol. If you take CH3, CH3, CH and OH. This sector of molecule is called isopropyl and it can be called it as isopropyl alcohol. Students, so in this way alcohols are derived. I am recalling, in water molecule, if hydrogen is replaced by the alkyl group, then it is called alcohol. If hydrogen is replaced by the phenyl group, that is called phenol. If two hydrogens are replaced by the alkyl groups, that is called ether. And we can discuss this in a different manner. If you take the alkane, if hydrogen is replaced by the OH, this is called methyl alcohol. If ethane, in ethane hydrogen is replaced, called ethyl alcohol. In propane, if it is replaced by OH, then it is called propyl alcohol. In the isopropyl alcohol, one hydrogen is replaced, called isopropyl alcohol. So normally we can define alcohols as alkyl substituted water, or we can define OH substituted alkyl groups. So this is the general introduction for alcohols. Now we entering into the nomenclature of alcohols, ethers and phenols, that also includes types of alcohols. Before to enter into the nomenclature, students, you have to learn, if the compound contains only one OH group, that can be called it as monohydric alcohol. For example, CH3, CH2, OH is a monohydric alcohol. If a compound contains two OH groups, it is the OH group 1. If you take two OH groups, then it is called glycol, or it is called dihydric alcohol. If you take three OH groups in the same compound, that is called trihydric alcohol. For trihydric alcohol, the best example is glycerol. And then if more number of OH groups are there, then they can be considered as polyhydric alcohols. What is the example for polyhydric alcohol? Glucose is the one example having the 5 OH groups. Fructose is the polyhydric alcohol having 5 OH groups. Sorbitol, mannitol, all are example for polyhydric alcohols. This is the simple classification based on the number of OH groups. If OH group is located on the alkyl group, simply called alcohols. If OH group located on the phenyl group, called phenols. If OH group located on CH2 double bond CHOH, if it is located on this group is called vinyl, and it is called OH, it is called vinyl alcohol. And if you take the OH group on a different group called CH2 double bond CH single bond CH2, this is called allyl alcohol, because this group is called allyl group. So it is called allyl alcohol. So on the nature of the alkyl group in the given alcohol, they can be classified as alcohols, phenols, vinyl alcohol, allyl alcohol, like that. Based on the number of OH groups, monohydric alcohol, dihydric alcohol and trihydric alcohol and polyhydric alcohol. For polyhydric alcohol, the best example is glucose and fructose and sorbitol. I want to show the structures of glucose and fructose. These are the examples for polyhydric alcohol. What is a polyhydric alcohol? Alcohol contains more number of OH groups. Here the best example is sorbitol. Count 1, 2, 3, 4, 5, 6. 6 OH groups are there. So more number of OH groups are there, that can be considered as the polyhydric alcohol. Sorbitol is a polyhydric alcohol. And come to the glucose. Glucose and fructose both are polyhydric alcohols. Here 1, 2, 3, 4, 5. 5 OH groups are there. Come to the fructose, 1, 2, 3, 4, 5. So fructose contains 5 OH groups, glucose contains 5 OH groups, sorbitol contains 6 OH groups. So these are classified as polyhydric alcohols. Before to enter into the nomenclature, student let to know the something about the primary alcohol, secondary alcohol and tertiary alcohol. If you take the OH group on the carbon, if that carbon particularly linked with one alkyl group is called as primary alcohol. Students, what is a primary alcohol? Primary alcohol is the alcohol in which OH group located on the carbon that is having connection with only one alkyl group. If you take the OH group on the carbon, but that carbon is connected to two alkyl groups, that can be considered as a secondary alcohol. That can be considered as secondary alcohol. OH present on primary carbon, simply primary alcohol. What is a primary carbon? Carbon which is connected to one alkyl group is considered as a primary alcohol. If carbon connected to two alkyl groups, that is a secondary carbon. That secondary carbon having OH group called secondary alcohol. And you will take the carbon which is connected to three alkyl groups, and these three alkyl groups are present on one carbon. It is called tertiary carbon. The tertiary carbon having one OH group, so it is called tertiary alcohol. Student, I am recalling, it is a primary alcohol, it is a secondary alcohol, it is a tertiary alcohol. Basing on the position of the OH group, alcohols are classified into primary, secondary, tertiary. Students, take a look. These are the examples for polyhydric alcohols. Now we are going to club these two issues. In this sorbitol, how many primary alcohols are there? How many secondary alcohols are there? How many tertiary alcohols are there? Student, this is the carbon. It is connected to one carbon, and the remaining two groups are connected by the hydrogen. So it can be considered as a primary. And now this carbon having one hydrogen and two carbons, so it can be considered as a secondary. Taking this carbon, it is connected to one more carbon here, one more carbon here, and connected to hydrogen, so it also considered as a secondary. Taking this carbon connected to one more carbon and one more carbon and then two hydrogen, so it also considered as a secondary. So last but one, here carbon connected to carbon and connected to carbon and connected to hydrogen, so it is considered as a secondary. Finally, this carbon is connected to two hydrogens and connected to one more carbon having one OH group. This can be considered as or classified as a primary. So in the molecule of sorbitol, number of primary OH groups, number of primary OH groups or primary alcoholic groups are 2, number of secondary OH groups are considered as 4. No tertiary OH group here. Similarly, you will examine the glucose molecule. This is a secondary, this is a secondary, this is a secondary, this is secondary, and it is primary. So number of primary OH groups here is 1, number of secondary OH groups here is 4. And then examine the fructose. In the fructose molecule, this carbon is primary and this carbon is secondary and this carbon is secondary and this carbon is secondary and this carbon is primary. So how many primary alcoholic groups are there? Primary OH groups here is 2. Number of secondary OH group here is 3. So this is the information recording the primary, secondary, tertiary alcohols in the polyhydric alcohols. Then we enter into the nomenclature. Here we are going to discuss nomenclature of alcohols, phenols and ethers. First, we are going to discuss about the nomenclature of alcohols. Generally, student thought that nomenclature means only IUPAC nomenclature. But IUPAC nomenclature is the standard nomenclature. Wherever the new compound is discovered, its name is defined by based on some rules. But some vital names or some common names are there. Common names is also very important for the exam point of view. So here I am taking the all possibilities for a given compound. So first I am taking a compound and I am going to write its common name and then its IUPAC name. So majority of the students are familiar with the IUPAC names, and then carbinol name. What is a carbinol name? This is the major doubt for majority of the students. Before the IUPAC nomenclatures, these alkyl substituted water molecules, simply alcohols, are called it as carbinol, carbon containing OH group. So carbinol, one carbon and one OH is called as carbinol. So that's why I am taking the carbinol system and also taking the IUPAC system and also taking the common name. Taking an example of CH3OH is if you take the H and OH, if you replace this hydrogen with the methyl group, you are getting the CH3. So it is called methyl substituted water molecule is nothing but methyl alcohol. So here common name is methyl alcohol. So it is these common names are simply derived in this way. Alkyl alcohol. If you are taking the methyl, methyl alcohol. If you are taking the ethyl, ethyl alcohol. If you are taking the propyl, propyl alcohol. In this way you have to write all the names. CH3, CH2, OH. That means water molecules one hydrogen is replaced by the ethyl. So it is called ethyl alcohol. And come to here, in this example, this propyl group replaces the hydrogen of the water molecule. So this compound, this part of the molecule is called propyl. So it is simply called propyl alcohol. And then go for the next example. Here I am writing on board. This is called this structure. This structure is called isopropyl. Students have to learn this is called isopropyl. What is called isopropyl? Isopropyl means CH group having two methyl groups called isopropyl. This is isopropyl. What is called isobutyl? CH3, CH, CH3, this is called isobutyl. The group with this structure can be considered as iso. So here it is called isopropyl. It is called isopropyl alcohol. In the water molecule, hydrogen is replaced with the isopropyl group, so it is called isopropyl alcohol. And come to here, this is the butyl. It is a normal chain, N-butyl. In water molecule, hydrogen is replaced by the N-butyl, so it is called N-butyl alcohol. And come to here, this CH contains one CH3 group and one C2H5 group. This can be called it as secondary butyl. In water molecule, this hydrogen is replaced by the secondary butyl group. So you can call it as commonly secondary butyl alcohol. This is the nomenclature, common nomenclature. This is the way of common nomenclature. Now we are entering into the important zone, that is IUPAC nomenclature. Here student want to recall the root words. If one carbon is there, you can simply call meth. If two carbons are there, eth. Three carbons are there, prop. So you have to recall. So here only one carbon is there, and for this functional group, the important suffix is OH. What is the suffix for the alcohols? Vol. For functional group is OH and its suffix is vol, and it is a saturated compound. You have to write ane. So it is a combination of meth plus ane, because all bonds are single bonds. This A is replaced by its suffix. Its suffix is vol, so its resultant is meth plus ane plus vol. So its name is methanol. According to the IUPAC convention, the name of the organic compound composed of three parts. One represents the number of carbon atoms, second part represents nature of the bond, and the last part represents type of functional group present here. Meth represents one carbon, air represents a saturated compound or compound having only single bonds, and OL represents alcohol. So its IUPAC name is methanol. Come forward for the another molecule. Come forward for the another molecule. Here how many carbons are there? 2 carbons. If 2 carbons are there, you have to write eth. And it is a saturated or unsaturated. How we identify whether given compound is saturated or unsaturated? Very simple, no double bonds are there, so it is a saturated compound. In this saturated compound all bonds are single bond, so you have to write the word ANE. But you want to continue its name, so you have to write only AN and then OH suffix is ol, so finally its name is ethanol. Similarly, you have to write the IUPAC names for the remaining compounds. Here how many carbons are there? 3 carbons. Here OH group located on, here 2 carbons are there. So if OH is there on this carbon, you can be call it as a first carbon. Suppose if this OH group present on this carbon, then it is called first carbon. So students, no hesitation to write the number for the OH groups. But here is a scenario, in this scenario, OH group is located on this carbon, you will give its number. So it is called prop N 1 volt because OH group located on the first carbon atom. Come to here, OH group located on the second carbon atom. For this molecule, prop N 2 volt. And come to this molecule. Here how many carbons are there? 4 carbons are there. So 1, 2, 3, 4, your OH group located on the first carbon. So you have to write butane 1 volt, butane 1 volt. And here OH group located on the second carbon. So you have to write its name as butane 2 volt. This is the way of nomenclature for the simple molecules, and then enters into the carbinol system. In the carbinol system, how can we write the nomenclature for the different alcohols? Students, you have to remember one carbon and one OH group is called as carbinol. So taking this example, CH3OH, one carbon is there and one OH group is there, so its name is carbinol. Come to the next molecule. Here one carbon and one OH groups are there, but this contains one more methyl group, so it is called methyl carbinol. And then come forward for the next molecule. This carbon and OH group can be considered as carbinol. This carbinol has a ethyl group, so its name is ethyl carbinol. And then here this is the carbon having the OH group, this is called carbinol. There are 2 methyl groups, so it is called dimethyl carbinol. And then come forward for the next molecule. This is called carbon and OH called carbinol having the propyl group, so propyl carbinol. And then last molecule, here this is the carbon and OH called carbinol and the CH3 and the C2H5, so it is called ethyl methyl carbinol. This is nomenclature of different simple alcohols. In this session I am going to conclude the nomenclature of the simple molecules. In the next session we are going to discuss on the some complex molecules and their IUPAC nomenclature and carbinol names of alcohols.